Good morning, science students, and welcome to our first online science class. You're going to notice today that we're going to be covering a topic that we talked about before we went on break, and that is density. So we already have learned how to calculate density. However, today we're going to go over that concept as it's going to tie into the lessons later this week and into next week. So for today, you're going to need a few things. You're going to need a calculator, some lined paper, and an erasable pen or pencil. If you don't have those things, you can go ahead and pause the video right now and collect them and then just come back to go through the rest of the lesson. But if you do already have those things, then today you're going to write down the date at the top of your paper. Today is Monday, March 23rd, 2020. And your title for today's lesson is going to be a density review. So you can just write that at the top of your paper. Okay, so just moving forward, I have a question for you. What do you think would take up more space if we're thinking of volume? Volume is the amount of space that something takes up. Would you think it would be a kilogram of feathers or a kilogram of steel? Looking at these pictures down here, I have a kilogram of feathers or kilogram of steel. If you're thinking that the kilogram of feathers would take up more space, you're correct. And that's because the molecules, atoms, or particles within the feathers don't have the same degree of compactness or closeness together as this ball of steel. And we would need a lot more feathers to make up that weight or that mass of 1 kilogram. So then I guess we could say we've already learned that density is a ratio, but density is the measure of the compactness or how close the atoms or molecules are to each other within an object. So I'd just like you to write that down here. So I'm just going to underline what I'd like you to write down. So in your notes, under your heading, you can write down that density is the measure of the compactness of a material. And basically that just means how close the atoms or molecules are to one another. So more than heaviness, density includes how much space an object takes up, or basically its volume. Okay, so this is something's volume, the space that it takes up. You'll have to excuse my writing here. I'm learning how to use these tools as we go along. So here, that how much space an object takes up is its volume. So you can write that down as well. And we know that all substances have density. So liquids, solids, and gases all have density because they all have particles that have mass, and they all take up some sort of space, whether it be compact space or very not compact, like a gas. Okay, so I'm just going to erase this here. And if you needed to, you could have paused on the video or back that up and finish copying that down into your notes. But I'm just going to erase this off our screen here. Perfect. And back to our mouse. Okay, so in this little diagram here, you can see the particle arrangement up above here would be more like in a liquid, where we know that the particles have weak enough attractions where they can slip and flow past one another, whereas we see this regular arrangement, that would be more of a solid, and therefore a solid would have more density than a liquid due to the compactness or closeness together of those particles, atoms, or molecules. Okay, so if we were thinking of volume as the amount of space, and I have a small space like this, and I have particles within that space. And then if I had the same amount of space taken up, the same amount of volume, let's pretend that those are very similar, but I'm going to add in more stuff. I'm going to add in more molecules, more particles in the same amount of space. Therefore, the particles are becoming more compact. Which do you think would have a greater density? I mean, they both take up the same amount of space. So which one would have the greater amount of density? If you're thinking this one here, you're correct. Okay, that one is because it has more particles, more mass in the same amount of space. Therefore, it has a greater density than the one before it. Okay, so we are familiar with the density formula. So I just want you to take a moment to pause this screen and write down the formulas that you're going to be needing for the rest of today's lesson. So for example, in order to calculate density, density is equal to the mass divided by the volume. And that's what these little letters stand here. The M is for the mass. Okay, and our mass is always going to be written in grams or centimeters cubed. So we'll write that down as well. So mass is going to be in grams for solids, or it's going to be in centimeters cubed if I have like regular objects that I can use like a density formula. Okay, so mass is going to be in grams or centimeters cubed, and volume is going to be mass is going to be in grams and volume is going to be in centimeters cubed, or milliliters, what we had said before. So centimeters cubed, I apologize, is for regular objects, and milliliters for liquids. Okay, if we were going to be trying to find volume, to find the volume of an object, I need its mass, and I'm going to divide that by its density, if I know the density. So it's going to be its mass divided by its density. And then if I wanted to find the mass of an object, I would then be taking its density and multiplying that by its volume. So to find the mass, I'm going to take the density and multiply it by its volume. So if you would like to just pause the video here and make sure you write those 3 formulas down on your page. Okay, moving on. So we already know that density is mass divided by volume. So the units for density are grams over centimeters cubed. So I'd like you to write that down, that the units are grams over centimeters cubed. This is the units for density. So the units here are grams over centimeters cubed, or if it's in milliliters, we can express that volume in milliliters. So it could be grams over milliliters as well. Okay, so just take a minute to write down the units are going to be in grams over centimeters cubed, or it can be in grams over milliliters. Okay, so make sure you just write those 2 down. Okay, so moving on here. We're going to do a few problems together. Okay, so for the problem number 1, I would like you to write down problem number 1 at the top of your page, and that this is just a density practice problem. So in this problem, we're going to be finding density. Okay, so just take a moment to write that down, and then I'd like you to write down the question. So the question number 1 is, a block of aluminum occupies a volume of 15 milliliters. So it's telling us that the volume here is 15 milliliters, and it weighs or has a mass of 40.5 grams. They want us to find the density. So looking back at our page, we need to find the equation that it's asking us to find. So it's asking us to find density. So that means I need the density equation, where density, and I want you to write down the equation as well. Density is equal to mass divided by the volume. Okay, so that's the formula that we're going to be using. And then we're going to be subbing in the values that we're going to find in this top problem. So we know that mass, like we had said earlier, we wrote down the units. Mass was going to be shown to us in grams. So this must be our mass here. So I'm going to put that in the top of our equation as 40 and 5/10 of a gram. Okay? And now I'm going to put that over or divided by the volume. And you'll see the volume here is shown to us in these milliliters units here. So our mass was in grams. And we have a liquid volume here, so it's in milliliters. So that's going to go underneath. 15 milliliters. So we're going to take our calculators now, and we're going to divide that out. So I'm going to type into my calculator 40.5 divided by 15, and we should all have an answer of 2, looks more like a Z, 2.7. And our units, what are our units going to be again? Remember we said it could be grams per centimeters cubed or grams over milliliters. And in this case, it's going to be grams over milliliters. Okay, so just take a moment to pause the video and make sure you write down that practice problem number 1. Okay, we're going to move on to density problem number 2. And for this problem, we're actually going to be finding density, but we're going to be using a volume formula. And we're going to be using the volume formula for a cube. You could use the volume formula for a rectangle. And the volume formula for a rectangle, I'm sure we all know, is volume equals length times width times height. Right? But for a cube, we know that all sides are the same length in a cube. So the volume formula for a cube is side times side times side, or simply side cubed. Okay, so now down to our problem. We have a cube of an unknown substance, and it has a side length of 3 centimeters. And we know that each side is the same, and the mass of this unknown substance is 10 grams, or 10 G. So we need to know what its density is. So we're going to be using the same density formula as we did before. Density is equal to mass over volume. So we're all going to write down the formula. It's always good to write down the formulas and sub in so that you can see the progression of your work and what you've done on your page when you go back to study. So here we have the mass, which is 10 grams. It tells us that right there with the G, 10 grams. But how am I going to find the volume? I'm going to actually have to calculate this volume out with the formula that we've put up here. Volume equals side times side times side, or side cubed. So that'd be 3 times 3 times 3, right? So when we multiply that out, grab our calculators. I want everyone to go 3 times 3 times 3. So we get a volume of, everyone should have on their calculators, 27 cubic centimeters. So that's our volume, this centimeters cubed. So we're going to put that on the bottom. Centimeters cubed. Perfect. Okay, so now we're going to divide that. And we have our 10 grams divided by 27. And our density of this unknown object is 0.37. And what would our units be? Grams per centimeter cubed. There we go. Bear with me as I write that. There we go. Doesn't look the best, but grams per centimeters cubed it is. Okay, so do you think that this unknown object would float or sink in water? Remember when we talked about floating and sinking before the break? And water, we said, had a density of 1 gram per milliliter or 1 gram per cubic centimeter. So if this unknown object is 0.37 grams per cubic centimeter, do you think it would float or sink in water? Well, since this unknown object's value is less than 1, it would actually float on top of the water. And that is because it is less than water's density. It is less dense than water. Anything that's less dense than water will float. And anything that's more dense or greater than 1 gram per milliliter or 1 gram per cubic centimeter will actually sink in water. So we had learned that before the break, but I just wanted to throw that little review in there for you. Okay. All right, moving on to our next problem. If you need to pause the screen and write all of that down, please do. Okay, I'm going to erase this up here. There we go. Okay, so next I want you to write down problem number 3. And this is finding mass using density and volume. So in this problem, we're actually going to be finding mass. So that means you need to go back up to your 3 density formulas and find the one for mass. Okay, so we've found that our formula to find mass is actually mass is equal to density times volume. So in our problem, we have a piece of copper has a density of 8.96 grams per cubic centimeter, and it has a volume of 88 cubic centimeters. So we need to know what the mass of this piece of copper is. So it already tells me that the density value is right here. So I'm going to sub that in. Right, so I have 8.96 grams per cubic centimeter. And I'm going to multiply that by, just do a little multiplication thing here, by the volume. And the volume here is 88. I'm going to put in my 88 cubic centimeters. Okay. So these values here, these cubic centimeters, should actually cancel out because one's on the bottom of this division sign and one's on the top. So they would cancel out and we'd be left with grams. And that's what we want. We want to find the mass. So we're going to take our calculator now and we're going to multiply our 8.96 by our 88. And everyone should see that on our calculator, the answer is 788.48 grams. Oh, I'm pulling that down with me. 48 grams. Perfect. Okay, just take a moment then right now to pause and write down these notes in your book. And then we'll move on to the next question. And it's the last question for today. Okay, I'm just going to erase this bit over here. Okay, the last question for today says that we're going to be finding the volume using density and mass. So problem number 4 is finding the volume. So today we're going to be finding volume. So that means you need to go up again to your 3 density formula variations and find the one for volume. So volume, and you'll see, is equal to the density divided by the mass. So back to our problem, we have a shiny red ruby and it has a density of 3.97 grams per cubic centimeter. If the ruby has a mass of 288 grams, what is its volume? So here we're going to simply sub in, and the density here is 3.97. We'll write that in, 3.97. And we're going to divide that by the mass of 2.88. 2.88 grams. Oh, I didn't put the units in for the over here. And this is supposed to be grams per cubic centimeter. Now, when I divide those out on my calculator, everybody get their calculator, punch in 3.97, the division button, divided by 2.88. And the volume is going to be 1 decimal, and we're just going to round this, 3 8 cubic centimeters. And that's our volume of our ruby. Okay, excellent. So just take a moment then to finish writing down that problem and the answers. And then I'm going to show you where your follow-up work will be. So I'm just going to give you a minute to finish writing that down as I clean this area up. And that. Okay, perfect. Okay, so we have a few follow-up practice problems. So you did receive an email telling you whether you were going to be working on group 1 problems or group 2 problems. So that'll tell you which calculations you're going to be doing. So you're going to be working on the calculations with today's note. And when complete, you can either take a photo of your completed work, or if you did your completed work in a Google document, and you can either attach or upload that photo or share with me to my email your shared document, and then I will send back the answers to you so that you can see which ones you got correct, or if you need to take up any questions during our Zoom call later today. We'll also go through a few more examples together on the whiteboard, some more complicated ones that I probably couldn't draw with today's tools, but we'll do that during our conference call later this afternoon. Okay, guys, it was good to teach with you all this morning, and I can't wait to see you all later this afternoon. Have a good morning, and we'll see you soon. Bye for now.